Hey everyone, welcome back to Italian News Channel. October 7th, 2025 marked a historic day for Python developers worldwide. Python 3.14 just dropped, and I'm not exaggerating when I say this is one of the most transformative releases in Python's history. We're talking about features that fundamentally change how Python handles concurrency, performance, and even how we write code. So grab your coffee, settle in, because we're diving deep into everything that matters. Before we get into the technical details, let me paint you a picture of what Python 3.14 actually represents. For years, Python developers have dealt with the global interpreter lock, that infamous GIL that prevented true parallel execution. We worked around it, complained about it, and accepted it as part of the Python experience. Well, that era is officially over. Python 3.14 doesn't just improve on what came before, it introduces entirely new paradigms for concurrent programming that put Python on equal footing with languages like Go and Erlang. But it's not just about concurrency. This release includes template strings that make SQL injection a thing of the past, a completely redesigned garbage collector that dramatically reduces lag spikes, and performance improvements that can make your code up to 30% faster in specific scenarios. Let's break down what all of this actually means for you. The headline feature, and I mean the feature everyone's been waiting for, is that free threaded Python is now officially supported. This isn't experimental anymore. This is production ready, battle tested, and backed by Python core team. What does free threading mean? Simply put, your Python code can now truly run on multiple CPU cores simultaneously without the global interpreter lock getting in the way. Now, there's a performance trade off you should know about. When you run Python in three threaded mode on a single thread, you'll see roughly a 5 to 10% performance penalty compared to regular Python. But here's the important thing, the moment you start using multiple cores, the penalty disappears and you get genuine parallel execution. For CPU intensive workloads like data processing, scientific computing, or machine learning inference, this is absolutely massive. The Python team made it clear this is just phase 2. Free threading is supported and stable, but it's still optional. You need to explicitly build Python with free threading enabled. The decision about making it the default is still down the road, and it depends on how well the ecosystem adapts. But make no mistake, this is the future of Python. Hand in hand with free threading comes another groundbreaking feature, multiple interpreters in the standard library. For over 20 years, CPython has supported running multiple isolated Python interpreters in the same process. But this was only accessible through the C API. Now, with the concurrent dot interpreters module, you can do this directly from Python code. Think of interpreters as having the isolation of separate processes but the efficiency of threads. Each interpreter has its own global state, its own import system, and by default, no shared memory. This gives you true parallelism even without free threading, and it opens up concurrency models that were previously difficult in Python, like the actor model or the communicating sequential processes. There are some limitations right now. Starting each interpreter hasn't been optimized yet, so there's overhead. Memory usage per interpreter could be better, and not all extension modules from PyPI are compatible yet, though the standard library modules work fine. But the foundation is there, and as the ecosystem catches up, this feature is going to enable entirely new ways of structuring Python applications. Let's talk about security and a feature that's going to change how we build web applications. Template strings, or T strings as they're called, are here. These look like F strings, but instead of F prefix, you use a T. The magic is that T strings don't immediately evaluate to a string. They evaluate to a special template object that contains both the static parts and the interpolated values. Why does this matter? Because now you can write template functions that have access to the structure of your string before it becomes a string. Imagine building an SQL query with regular F strings. You're asking for SQL injection vulnerabilities. With T strings, you can write a function that properly escapes and parameterizes your query automatically. Same goes for HTML shell commands or any context where mixing untrusted data with code or markup is dangerous. This isn't just safer, it's also more powerful. You can build domain specific languages, custom formatters, and templating systems that integrate seamlessly with Python syntax. And because T strings use the same familiar F string syntax, there's almost no learning curve. Here's a change that might sound technical but has huge practical implications. Annotations are no longer evaluated when you define a function or class. Instead, they are stored in a special annotate function and only evaluated when something actually needs them. This is specified in PEP 649 and PEP 749. What does this mean for you? First, performance. Your code starts faster because Python isn't spending time evaluating type hints that might never be used. Second, forward references become trivial. You know how you sometimes had to put quotes around type hints because the class wasn't defined yet? That's basically gone. You can write forward references naturally and Python handles them correctly. There's a new module called annotation lib that gives you fine grained control over how annotations are evaluated. You can get them as runtime values, as forward references, or even as strings. This gives library authors incredible flexibility while keeping the simple case simple for everyone else. Let's talk speed. Python 3.14 introduces a new interpreter architecture that uses tail calls between small c functions instead of one giant switch statement. When you build Python with Clang 19 or newer on x86 64 or ARM 64 architectures, you can enable this new interpreter and results are impressive. Now, I need to be honest with you about the numbers here. The Python team initially reported 9 to 15% speed up across the benchmarks, but they discovered a compiler bug that was making the old interpreter slower than it should be. After accounting for that, the conservative estimate is 3 to 5% geometric mean improvement, with some workloads seeing up to 30% gains. That might sound like they walked back the claims, but here's what matters. This is real measurable improvement and it's only going to get better as compiler support improves. The incremental garbage collector is another huge win. Python now collects garbage incrementally instead of stopping the world periodically. For applications with large heaps, this reduces maximum pause times by an order of magnitude. If you've ever had your web server hiccup during a garbage collection, those days are largely over. Beyond the big features, Python 3.14 is packed with quality of life improvements. The interactive shell now has syntax highlighting turned on by default. When you type code in the REPL, it's color coded just like in your editor. Import autocompletion is there too. So typing import and hitting tab actually suggests modules. The debugger got a major upgrade. You can now attach PDB to a running Python process remotely using the new safe debugger interface from PEP 768. Just run python-m pdp-p and process ID, and you're debugging live. There are also new Essentio introspection tools that let you visualize the task graph of a running async application, which is invaluable for debugging stuck coroutines. Error messages are better across the board. If you misspell a keyword like writing will instead of while, Python suggests the correction. Unpacking errors tell you how many values you got versus how many you had expected. Exception handling with parenthesis is now legal for multiple exception types when you don't need the as clause. These might seem small, but they add up to a significantly better development experience. The standard library got some love too. There's a new compression.zstd module that brings Z-standard compression to Python. Z-standard is fast, efficient, and widely used in production systems. The trifle, zip file, and shuttle modules all support it now. Pathlib gained methods for copying and moving files. You can finally do path.copy or path.move directly without reaching for shuttle. The argparse module now has colored output by default, and it suggests corrections if you mistype a command line argument. The http.server module supports HTTPS now with command line flags for certificates. There's also a new annotation lib module for working with deferred annotations I mentioned earlier. And on Windows, the zlib module now uses zlib-ng under the hood, which gives you better compression performance across the board. Now, not everything is backward compatible, and you need to know about these changes. The biggest one affects multiprocessing. On Linux and other Unix like systems, the default start method changed from fork to fork server. This is safer and more compatible with threading. But if your code relied on fork semantics with shared mutable state, you might need to explicitly request fork mode or refactor your code. The from future import annotations directive is now considered deprecated. It won't be removed until Python 3.13 reaches end of life in 2029. But the writing is on the wall. The new deferred evaluation makes it unnecessary. We are using the Asensio event loop policy system. That's deprecated too and will be removed in Python 3.16. You should migrate to Asensio.run or Asensio.run with a custom loop factory if needed. Python 3.14 represents a fundamental shift in what Python can do. Free threading removes the GIL bottleneck. Multiple interpreters enable new concurrency patterns. Template strings make security easier. Deferred annotations improve performance. And a host of smaller improvements make Python more pleasant to use every single day. This release will receive security updates until approximately October 2030, giving you 5 years of support. Whether you are building web applications, data pipelines, machine learning systems, or anything in between, Python 3.14 has something meaningful to offer. Well, that's it for today's deep dive. If you found this valuable, hit that like button and subscribe to Italian News for more coverage of the latest in development and technology. I have included an easy installation guide in the description box below. I'm your host from Italian News channel. Until next time, keep coding, keep learning, and I'll see you in the next one.